My name is Ana Baotić. I'm from Croatia, and I will be talking to you about how you can break your apps and why you should do it while you don't push them out for other users to do the same. So just to give you a brief overview what we will be covering today, we will talk about app coverage, things you already do, most of you do, most developers tend to do. We will discuss what we can see in the APK and how to see it. We will also overview some of the tools that you can use without any prior knowledge or effort to inspect your applications, maybe change them a little. And we will have a conclusion on why this is something every developer should be doing while they're creating applications. So the first thing that we all start with when we create a new project is probably static analysis, because that's the proper time to set it up. You want your code to be stable, you want your code to be good and maintained, and you want your colleagues and your future self to have a product that they can be proud of. Which means that you won't be placing random constants all over the project, you won't be hard coding stuff. It's just proper house cleaning and housekeeping that you need to do with every project that you make. It's about improving code quality, and that's the basis of everything. Because in some future development, you might be changing stuff in your code, and if you have it hard-coded in one place and export it to a constant in another, chances that something will cease working are just great. You usually add lint also to your projects, because lint can give you some warnings that you might not be aware of. Security warnings, code quality warnings, basically anything that can help you improve your product. It can kind of point you in the direction that some things are not safe or can be changed or should be changed. I just added 2 examples here from the documentation that's very concise and easily readable, obviously. One is secure random. If you use it somewhere in your application, what the warning is it a security level or something else, or if you should change it with something different. What I found to be quite a good addition to building an application is the DevNox Android Studio plugin. It can be useful for some things. For instance, I hadn't heard about the tab jacking attack until I added it to one of my projects. Basically, if you're not familiar with it, you can place an overlay on the application and you can steal the input from your user, which basically means if you're inputting some kind of password and username, you could be in a lot of trouble. Not only you, but the users that basically use your app. So it's a good thing to add, and it can add an extra layer of security while you're developing. You can also scan just a part of your application, the whole application, a custom scope, so there's no reason not to add it. Here is a brief overview what it looks like, like a report when you run it for the app. So like I said, the tab jacking thing, I hadn't heard about it before, and it's basically quite common. It was present in the Android 4, I think, and it was reintroduced later on, so it's definitely something that you should take care of. And yesterday we had a couple of talks about testing, which we all love and adore. We all test applications, at least I hope we all do. It's basically doing testing is like a present for your future self and your team and your product, because I don't know if you work in an agency or in a specific product, but sometimes the specification might not be all too detailed. For instance, we had projects where the client would say, oh, we would like a few buttons there, and it should show something very, low-level descriptions. And basically tests are what we consider to be proper specification later on, because you describe how your app is supposed to work. What the business logic is, if your UI is displaying correct data, it's basically making sure your app doesn't break from the inside. And also, when you add new features to your applications, chances are that something might break in one of your previous developments. So you change one thing in one part of the application, and if you don't have the architecture right, or you might have not set up the MVP properly, or you just have some leftovers from previous developments, this is probably the time that you might be seeing some errors. And testing is a way to mitigate that, because it's better if you see something break while you're developing rather than when it goes out to the public. So it's kind of a legacy to take care of. And one of the most important things during development, and I cannot stress this enough, is having a good QA team. 1, 2, 10, it doesn't matter, but you need people in your team that are specifically there to take your app, not listen to you on how you want it to work, but to take it and try actually using it. So preferably people who hadn't seen it before, who hadn't worked on developing it. This is important because I think that developers, and I'm sorry to say this, we are horrible testers. We take the shortest path. We solve problems for a living. So if we need to get from point A to point B, we will definitely take the shortest path. We will make sure that it works the way we think it should work. Users, on the other hand, are nothing like that. You will have people entering text where it shouldn't be. You will have people clicking randomly on the application. You need somebody erratic to go through the app and try to cause crash, or even tell you if some of the UI doesn't make sense. So basically, you need people to tell you what it's like to use your app. So good QA is mandatory. In my previous company, we had quite an energetic team who really enjoyed going through the app, and they would always come to you with a big smile. Oh, you know what crashed? Everything. And they would really enjoy breaking your day, not the app, well, also the app and the day. And although you might not like the approach, it's basically very useful because actual users are not, perfectly logical beings who will see the shortest path as we do. And we're also very biased because I've seen from personal experience that when I test my product, I usually just perform the steps that I know that need to happen. And I don't just go wild on the whole UI and press back and forth and home and try to, wreak havoc on the app. So good QA is worth gold. We also had a good talk yesterday from the Firebase team. And what was mentioned was Google Play, the alpha and beta channel, and the pre-launch report. I personally love that feature. So when the pre-launch report first rolled out and we pushed our first build, it was great to see our application on 10 or 11 or whatever number of devices. We could see the UI. We could see logs from 5 minutes of recording of random clicking on the app. And we also found that sometimes you can have like a Samsung device with Android 4 that breaks every time you run the app. So it's useful for catching those bug occurrences that might be specific to a platform, to a vendor, or a combination of both, which is basically very difficult to find if you're an agency or a small company or you just have five devices. So it's really a good tool and requires minimum effort from you, and I believe that everybody should be using it. So another thing that's very useful with this, like I said, you get 5 minutes of testing and you get the recording and images and screenshots, but you also get the log output, and you can see if you possibly left something in those logs that shouldn't be there, which happens. I'm going to raise the hand and say that I've left outputs that should not be there on numerous occasions in my 6 years of development. So, confession time. So, it also provides you with a security review. If some common issues have been raised, for instance, something with the web view, which is basically an issue in itself. Maybe you're using a Cordova in your app and you might be using an old version. Basically, it will raise an issue that you can address at that moment. It looks pretty. Well, the green part for the most looks pretty. And like I said, it's a useful tool which allows you to get an unbiased report for several devices. And this is a good way to test your app before you go live. Because once you go live, you can get one of these. So if you're using Fabric, I don't know, has anybody gotten a velocity report in their apps? Don't be shy. Here I go. Okay, so it happens. It might not be the best indicator that there's a huge issue in the app, because sometimes you have one user that will attempt to do something for 219 times. So this is persistence. I applaud this person. Maybe he just liked wasting 10 or 15 minutes just pushing one button, but it's okay. So crash reporting has a purpose. This might not be it, but there are situations where your Fabric or Crashlytics reports will do you a service and you'll be able to fix things quite easily. The biggest problem, from my opinion, on Android is the fragmentation. So while your iOS developers have 2 or 3 or 4 devices and screen sizes to take care of, we have this beautiful collage of chaos, which means that you might be able to cover most of the combinations, but probably not all of them. So using all of these tools together might help you mitigate this here situation that will probably not improve in the future. So all of these things, the static analysis, the testing, the beta program, the Crashlytics and the rest, we kind of make sure that our app doesn't break with our users. We make sure the business logic works. We make sure the UI looks good. We make sure that the application performs as it is supposed to. But sometimes you need to take a look on the inside. So depending on the scope of your work and the applications you work on, sometimes you might be mandated to have penetration testing done on your app. Has anybody been in that situation where your clients demanded your app to be penetration tested? 1, 2, okay, a few. So basically what your client or your product mandates is that you give your application to somebody and they will try to see if you are putting your users at risk. If you're leaking data, if they can get to sensitive data like passwords or tokens or anything that might cause them material harm. If you can get user data like pictures or messages, basically anything that invites privacy and security. So to be formal, basically a pen test is an attempt to evaluate the security and stability of a system. You're trying to exploit vulnerabilities if they exist or not. So what is the motivation for such a test? Well, basically, you want to make sure that your app and your users are safe. You want to make sure that their privacy hasn't been, invaded. And basically, you might just be mandated by your client to do so. So any of those scenarios are valid. So if you want to take a look at any APK, and I'm not just speaking about, penetration testing. Maybe you're just using an application that looks good. It has a cool feature, some kind of UI element that you want to look at. There's nothing stopping you from getting the APK from your device and taking a peek at it. So how do we do that? How do you get an APK directly from your device in less than 1 minute? Well, it's fairly easy. So for those of you who use ADB, like shell commands, you should really get acquainted with them because you can do so much. For instance, before I get into the whole APK and data in it and what to look at, let's say during your testing that you have a huge entry form, like you're trying to perform some kind of registration and you need to have tens or 20 like data items put in by your user, and your QA is going to you and say, nah, I'm not doing this. This is going to take forever. What do I know what the rules are? There's nothing stopping you from creating a script that will have like inputs, ADB shell, input text, something. You just construct the script and give it to them so they can run it. And they can fill the form in like 10 seconds or more. So knowing your ADB shell commands is very useful for you while you develop and for your QA team because it can save a lot of time. And nobody likes filling out forms and testing it. So let's start with what we set out to do. For you to list all the packages on your device, you have a simple command that says ADB shell PM list packages. So you might want to look at a specific app. You might want to look at a random app. When you take a look at those items that are listed, pick one. And for you to get that app on your device, you need to know two things. For Samsung, because I love Samsung applications and how they work, you just list, like again, packages, and you just want to narrow that output down with a grab command. And here you have 5 applications. So let's say we want to look at the video application. We need two things. We want to know the name of the APK on the device, and we need to know where it's at. So we query for the path. Simple enough. And we get where the APK is and what it's called. And at this moment, we have everything we need to pull that APK to our Mac or other device. So again, ADB pull, you give it the APK, and that is for current directory or whichever directory you want on your device. Now you have the APK to look at. And I won't get into the details of an APK. As you know, it's nothing but a glorified package. But this is its content, and we will try to look at some of the stuff here. At this moment, I'm going to, spill the beans. We can't do much with this. So we cannot read it, we cannot interpret it. We can look at the assets, we can try to look at the resources. Android manifest is not really interpretable, so it's not in humanly readable form. How do we get something that we can actually look at? Here's a list of tools in general that you might want to use when you're trying to look at your application. And when I say look at your application, I mean it loosely because you can always look at your code. But sometimes if you want to look at some other application that you find interesting or you want to explore it a bit, or let's call it code review, if you want to know the internals of that application, nothing malicious, of course, then these are the tools that you might want to start with. So AAPT, the packaging tool, it can provide some info about your application. Not much, there are better tools, but we'll get to that later. So it's a part of the SDK, so you have it on your Mac. I presume, of course, that you're using Mac, but whatever other computer that you might be using, it's in the SDK. So you need not install or get anything. You have everything set up. So how do you list the content of an APK? Fairly easy. AAPT list, and you give it the APK. And you can see here what the contents are. So if you want to look at the strings that are contained in the APK for whatever reason, you can do that too. Fairly simple. So AAPT dump strings, cool APK. You can get a list of all the commands in the reference part of the presentation. I won't go into that more thoroughly now. But basically, you get a full list right now without doing much work. What if I want to look at the Android manifest file? I can do that too. It will list all the items that are in it. Like I said again, no effort. You can do this in parallel while I'm talking about it. You won't waste any time. So, what if you're a bit cautious and you want to install an APK, but you want to take a look at it before it gets to your device? For instance, you have a cool, let's say, video app, and you want to look at the permissions that are in that application, And you can do that without putting it on your device and waiting for the pop-up to raise, or if it's like an older app, you will get the list immediately. So, apt dump permissions in the APK, and you will get all of them. And this is a good way, I mean, if you're squirmish and you are cautious, you might want to have a red flag raised if you see that your video app is requesting SMS permissions or things that might cost you money and have nothing to do with the functionality of the application. So if you want to check it in advance, this is a good way to do it. If you're testing your own APK, there's obviously no reason to go through all that hassle, because you can just drop it in your Android Studio and use the APK analyzer. So you get all of it in your random debug build, and it will be listed in a readable manner. But let's go back to the console and see what we can actually do with the APK once we have it. I would like to add a random TXT file in the assets. So I'm not changing anything. I just want to see if I can add something to the APK. Turns out it's, again, scarily easy. apt add, let's call it The Last Jedi TXT, and I want it in the assets folder. This command will put it there. When I list the contents of the APK, I can see that it has been added to the assets. So basically no effort for you to insert something in the APK. We're not doing anything yet with it, but we can add stuff in it without any problems. So if we can add something, we can obviously remove something. Like we see here, if we call the remove command, we can see that it's no longer here in the assets. This is the part where things can get a bit destructive. So if your application is using some kind of HTML, like an info page in it that you display in a web view, and it has some kind of link to a page where you want the user to insert your username and password or something else, you can easily remove the existing HTML from the assets, and you can input your own with a different link, which would basically mean that the APK, if signed and installed on the device, would look normal to the user if they install it, and they would lead to the site that that's not valid anymore, that's not secure, that could steal their data. Okay, so once we've exchanged something here, we might want to check whether or not we can install it on our device. It turns out we can, because it needs to be re-signed. So each time you produce an APK, whether or not it's debug or production or whatever flavor you need, you sign it with a key store. And we need to sign this APK because its signature has been changed with the modification of data. And what you can do is use the YAR signer and just place any kind of key store. So if it's your application, you can obviously use the one you already had, and it will work. You'll be able to update the app from your device. If it's signed with something else, obviously you won't be able to update it, and any kind of other user won't be able to install it in parallel with your application. So you're good to go as far as that is concerned. And just a side note here, developers tend to keep their key stores, the ones that they sign the application with, in the same code base where they store the app itself. I'm really against that because you have a single point of failure. I'm not saying that somebody will go into your account or you will leave your credentials somewhere, they'll be able to get to it and steal it. But companies are usually big. There are several users. People leave, people come, and it's a good practice to keep it securely stored somewhere else. And of course, somewhere else where you actually know where it is, because I've seen situations where the developer would keep the key store on his device, and then he would leave the company and the laptop would be reset, and then you're kind of in trouble because you're not able to update the application ever again. And it's not a fun conversation to have with your clients. So this is the one thing to do. What I prefer to that is the APK tool. So it's a simple tool for reverse engineering APKs. you can do several stuff with it. You can disassemble resources. You can rebuild the decoded resources. And it's not difficult to use, and it's not difficult to install. Basically, all you need is Java 7 or higher. You need the APK tool jar, which is downloadable from the link. The presentation will be up and running soon. You have the wrapper script, which you can execute each time if you don't want to write, the whole command. And you just paste it in your user local bin and run it in terminal. You just need to make sure that it's executable, but that's not an issue actually. So if you set up your script and the jar in a proper way, when you run the APK tool, you get a list of all the things that you can do within APK. And it might be, a lot for the beginning, so we will just start with simple commands. So one thing to mention here, what you will have in the end when you use this, it will turn DEX files into Smalley files. So Smalley and box Smalley, it's Icelandic or Scandinavian, basically the names for the disassembler and assembler. And box Smalling gives us readable files that we can actually interpret. So you can box Smalley your own code. Sounds rude, but it's actually quite useful. So let's take a look. If you use the APK tool with d-f cool APK, you basically get this output, which tells you that it's loading the resources table, decoding the manifest, loading resources again, decoding. And when you take a look at what the output is, you get basically some of it, none of it is actually similar to when you open the actual APK. You get the manifest file, you get sslib, original, res, Smalley, unknown. And what we want to look at, just to start with something, is the Android manifest file. Now this is readable. This is nothing like what we've seen when we try to open the APK itself, on Archivit. And we can see actual data that's been placed in here. We can see the name of the icons. We can say the name of the application. We can see that it's using a network security config and lots of other data. If we take a look at the layouts, and this is the interesting part, if you're looking and reviewing the application that has a cool feature that you would like to re-implement, of course, you're not stealing, you're just getting inspiration from somebody else's work. Basically, you can take a look at how they achieved it, or if they're using some kind of third-party library that you can just import in your app, and you're good to go. So just looking at stuff. It's not formatted, but it's readable, and we can actually get around with this. So what if we want to rebuild our APK? Turns out it's fairly easy. So the B stands for build. It will take the whatever is present in the current location, and it will build the APK. So what you also can do is basically place it in some kind of other folder, but this is not very important. So you can take the application once you took a look at it, and you can rebuild it again. And if we take a step back and comment on the fact that we can add stuff and remove stuff, this is the place where it gets scary again. Because there's basically nothing stopping you from changing the icon of the application. You know where the assets are, you know how to place it there. You're just switching files. Again, you can change the other assets that are there, whether they are HTML files or some kind of data, JSON content that is used for rendering some kind of menu. Basically, once you explore the app and take a look at it, you can change anything. So again, I would like to try and install this application on my device. And again, we still have to sign it because it had been changed. So if you use the YAR signer again, and try installing the APK, we get success. So again, like I said, you're not in any peril if the user that's attempting this on your application doesn't have your key store and doesn't have your Google Play credentials, and that's okay. But there's also nothing stopping that person from creating a website, placing resources there that might mimic your application, place their APK on that site. And although they might not get users to update the APK because it's physically impossible with a different signature, there's nothing stopping them from getting users who don't have your application yet to install it. And that's a problem, because those users are at risk. They see the look and feel of the application. It can have the same package name because it's not on Google Play. Doesn't have to be unique. And if they are first-time users, they are at risk because they can download it and they can input their data and they might lose their data, their money. It's a huge issue, and it should be really, if you can in any way mitigate it, it's a good thing to do. So one thing that you can do is add some kind of tampering detection in your application. So if somebody does take the APK and changes stuff in there, you can possibly check whether or not the APK had been installed from Google Play. So you can check the origin, which means if it had been installed from some other site, there's a way to check whether that origin is the same or not. And you can warn your user, like with a dialogue, and tell them, hey, you've installed this from an unfamiliar, unsecure site. Please delete the app. Please submit some data and notify us what you had been doing. Because that's a good way for you to get feedback that there's something wrong and that your users are at risk. And it's a good way for the users not to get in trouble. There are other tampering detection techniques that you can use, for instance, to detect whether or not it's in debug mode, because the APK might not end up on a device at the end user. Somebody might try to debug it and just take a look what's going on, like if you're communicating with an API or sending data. There are various things that can go wrong and break more than just your application. So tampering detection is a good thing. So as you see, the APT tool is fairly easy to use, and sometimes it might not work. It depends on the framework files, but that's a different topic. So there's one more tool that you can use that's fairly simple and easy to go around with. So it's ClassyShark. You've probably heard about it. If you hadn't, like I said, it's fairly easy. You can browse components. You can take a look at the method count. There are other features there. I won't get into more detail here because it's. I believe that the APT is more than sufficient for you to get going. And when I say for you to get going, I'm addressing the people who actually haven't tried anything like this before. For me, the main motivation for taking a look at this kind of, like testing and taking a look at the internals was due to a penetration test report we got. So basically, you get items that you need to check on the client side, and some of them aren't really related to the application. They're related to the API and the content that's being transferred. But in my mind, when I heard that we had issues with the pen tests, I said, oh boy, this must be really hard. So we have a company that's penetration testing our app, and there must be, weird hermits with hoods in a black basement, and they're just, scary and doing some kind of black magic. And when I started, exploring this, I kind of got depressed seeing how easy it is to take a look at the basic stuff. So this is really basic stuff, and anybody here in this room can do it in a few minutes. So that's what it takes for you to, rip open somebody's work and check how they did stuff and maybe try to play with it a little bit. I'm not suggesting you do that, but I think that, learning is good. And for those of you who have had more experience with this, write a blog post, share your experience. If you've seen people do something, I'll be frank, stupid, you know, write a tweet, tell them, please don't do that, use some kind of other method. The security aspect and this whole thing, in my opinion, is not represented enough. So you have a gazillion posts about Kotlin, and you have even more about automated testing and design. And I kind of feel that the security aspect has been, you know, mystified and pushed back, and you only have basically posts and links to companies that perform work for you. I'm not saying they do it badly, but I think that some kind of knowledge sharing here could improve the whole process for the Android community. So let's stop with the rant. Another tool that you can use is the AndroGuard. It's written in Python. Basically, it has several options, a bit more advanced. Reverse engineering, malware analysis, and it's, like I said, a good tool. This is how you would normally get around to using it. So basically commands that are fairly simple to use. There are methods that you can call per your APK, like get permissions, services, receivers. So again, you can use systematic overview of your APK or somebody else's APK and take a look at it. And another thing that I really like, and what people tend to forget, is again that our users tend to be humans of flesh and blood, and that their data plan usually sucks. So when they go out and drive a car or go somewhere in nature, they might not get the full service that they need for your app to run smoothly. So when we're in our offices on Wi-Fi and everything is just blasting away with speed and bandwidth, it's okay. Everything runs okay and you get the perfect test for your app. But what you can do with the Charles proxy, and it's basically just a proxy application that you can monitor traffic with. You might use Fiddler or something else. You can simulate the actual conditions out there. So you might want to test your app on edge, or maybe throttle it, or you might want to, you know, just check the communication between the device and the API. So here, let's do a count raise. Does anybody use HTTP in their app? Okay, I won't look at the crowd. Actually, for those of you who use it, you might be, you know, using cryptography to encrypt your data and everything, but use HTTPS if you can. It's just like the basics. It's mandatory, in my opinion. It's the least you can do. And it's just, in my opinion, there's no excuse for sticking to HTTP because it's readable unless encrypted. So, like I said, Charles is a great tool. You can do the man-in-the-middle attack with it. Well, basically on Android, you could do that before Android N came out. With Android M and with several releases in the last few years, we can see that the security has improved greatly. We got the permission system, we got the network security config, which basically allows you to use, let's say, custom SSLs for testing and debug and development, because Android kind of tends to drop on the floor and say, nope, I won't do that if they know that the certificate is self-signed. It has a list of trusted authorities on it, and if you use something that's not in them, it will basically not allow your communication to continue. So what you could do before is use, let's say, a Charles signed certificate on your device, just place it, install it. But with Android M, the system doesn't really trust the user certificates on the device. So what you can do is add the network security config, and in it, you can tell, trust the system certificates, authorities, and also trust the user, which basically just goes around the issue, and you can still monitor your traffic and look what's being back and forth. And if we push the security part aside for just 1 second, situations here, you can repeat requests, you can intercept them, edit them, and this is really cool because if you have some kind of model that you're expecting in your app, because you have a great API team They always produce the same quality of their responses and requests, so you know what to expect. And sometimes you can just test the app whether or not the application is responding to a change in the response in a proper way. So just show something, don't show something, hide, whatever. But what if the API people send something different? So you're not expecting an object, they send you an array, or if you're really lucky, you might request some kind of data from the server and get a huge database exception in the form of HTML or something else because they're having a bad day. Your application should be able to continue working regardless of that. So prepare for the worst. You are expecting data, but that data might not come, ever. Or at least not in the form that you're expecting. So, one more thing to think about is that when you're transmitting data, again, that data might be critically important to the user. So whether it's a social security number, I don't know what critical data in the US might be considered, but passwords, usernames, any kind of, identifying data that might be used to, let's say, open an account somewhere or register for services at the telecom company, anything can happen. We've seen a lot of problems back home where some kind of data that was leaked, people would use it to open an accounts and just people would be in debts with bills that they didn't know existed. So it's a huge issue. So to wrap it up, I've listed a few things why you should pen test and take a look at the internals of your app. But I'm going to say just one thing. Basically, you want to do it for yourself. You want to make sure that your users are happy, safe. You want to be safe, probably. So the applications that you are using, I believe it's safe to assume that we expect nothing less from the developers of those applications. So it's like good manners or housekeeping, basically things that you need to do and you should do at least to provide the services that your users deserve and that you deserve. So my final words here is basically go and break something today. Yours or others, take a look at the APKs, learn something, and if you have some tips on how to do that and you want to share that knowledge, it would definitely be appreciated in the community. So thank you.